Okay, we're continuing with sketching sinusoids that have horizontal and or vertical translations applied to them. In the previous video, we sketched sinusoids that had strictly horizontal translations. Now we're going to look at sinusoids that have vertical translations. Okay, and the way we're going to go about this is we're going to go through the whole process that we did in the previous video of sketching the sinusoid, but ignoring the vertical shift. And then once we go to actually put the points in, like we would before, we're going to apply the vertical shift then. Okay, so, all right, here we can see that this is 2 sine x minus 3. So it's the graph 2 sine x shifted down by 3. All right, so now what we can think about in a similar way to how a horizontal shift didn't affect period, frequency, angular frequency, amplitude, because a shift doesn't affect the shape of the graph. Same thing with a vertical shift. From 2 sine x, this vertical shift isn't going to change anything about the period, frequency, amplitude, etc. Okay. Now the horizontal shift, the way you looked at that was that the phase changed, right? How far off from that standard zero defining position of sine or cosine has the graph shifted? That's the phase change. Well, the parallel to that with a vertical shift is the average changes, or I don't know what the technical term is, but the mean y value, that middle of the amplitude gets shifted. Okay, so here the amplitude is 2, so we're oscillating plus and, well, okay, if without a vertically shifted graph, you're oscillating between plus and minus 2. But if that mid value shifts down -3, then you're going to be oscillating between, the amplitude doesn't change, right? So you're oscillating between -1 and -5. Right? Again, because the amplitude doesn't change. The period, none of that changes. So, okay, that means let's do this. We want to do, we'll say, let's make this -10. Okay, now the period, there's no scaling about the x-axis, so the period's going to be 2 pi. So we'll do okay, now let's see. Oscillating between, each of these tick marks is going to be 1. So, yeah, -1 to -5. Yeah. Okay, now is there any horizontal shifting? No. So let's put the new midpoint region here. So I'll put this in light colors. 1, 2, 3. So there's the new mean oscillating value, the new zero value. I'm not sure what the technical name of that is, but okay. So now, okay, is there any shifting about the x-axis? No. Okay, so we've accounted for the amplitude of 2, because it's gone from 1 to 2, and then we've accounted for the vertical shifting down 3 units, and that's the only transformations. So, okay, there's no shifting, so we're gonna sketch from 0 to 2 pi. That's the period we're going to sketch, just like we did in the section 1. So, okay, the sine curve starts at 0, so this is the new 0, starts here, and it ends here. Okay, at the halfway point, it goes through that mid-range. Okay, at the quarter point, so let's see, it's going to, yeah, at the quarter point, it goes to the positive amplitude, which is here. And at the 3/4 point, it goes to the negative amplitude, which is here. All right. So like that. And there we go. So again, the period is still just 2 pi, amplitude 2, frequency all the same, and the difference is this mean value, mean y value that's the amplitude is oscillating between has been shifted down -3. That's the property that has changed here. Okay, so let's rewrite this. We could do, okay, minus 2 cosine 5x minus 1. Okay, so we've got a shift down 1 unit, scaling about the y of 2, a flip about the x, and a scaling about the x by 1/5. And then no horizontal shift. So, all right, let's see. Y, x. So the period is going to go from 2 pi to 2 pi divided by 5, which is what? So 2 pi divided by 5, 1.257. What is pi divided by 2? So, okay, let's do minus pi divided by 2 to pi over 2. All right, minus pi divided by 4. Okay, so let's see, minus pi divided by 8. And then pi over 4 plus pi over 8 is 3 pi over 8. All right. Now, let's think about we're shifting, the amplitude is 2, has been scaled to 2. So we're oscillating up and down 2 units. And so, but we're shifting that mid-range down 1, so we can do this. This should be good. 5 to -5. So each tick mark is 1/2. Okay, so let's put the new x-axis. So -1, that's here. Okay, no shifting about the x-axis. So, okay, we can go ahead and sketch or draw the points. The points at we're going to go from, let's see. Oh, okay, yeah, we need to mark off the period here. So, all right, each tick mark is pi divided by, so pi over 8 divided by 5 is pi divided by 40. So what is 2 pi over 5 divided by pi divided by 40? That's going to give us the number of tick marks 2 pi over 5 is. So 2 pi over 5 divided by pi over 40. 16. What? Oh, no, that's right. That's right. Because, yeah, that's right. This is 20 tick marks, and it's right inside. Going all the way out is 20 tick marks, and it's right inside pi over 2. So, yeah, 1, 2, 3. So here. And, okay, so there's the end of the period. We're starting at 0. Now, okay, so at the start, we have a cosine curve that's been flipped, though. So it's going to start the negative amplitude instead of the positive amplitude. And then, so here's the 0 point. And so, okay, it's going to start the negative amplitude, so go 2. But it's each of these tick marks is 1/2, so here. And then we're going to end at that same point. Okay. Now, halfway, we're going to be at the positive amplitude. So 1, 2, 3, 4, 5, 6, 7, 8. And then up 2. And then we're going to come through the midpoint at the quarter points. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. So like that. So now let's copy this. And there we go. And the main shift here, the property, is this shift in the average function value that's being oscillated around. Okay, so let's write this. Let's see, we've got minus 2 cosine 1/2 x plus 1. So we're going to shift up 1. There's no shifting horizontally. There's a scaling about the x-axis by a factor of 2 and a scaling about the y-axis by a factor of 2 and a flip about the x-axis. All right, so the period's going to go from 2 pi to 4 pi. All right, so let's see. Okay, now the amplitude is scaled up by 2, and then we've shifted up by 1. So let's do, this should be a good scale here again. All right. So now let's put the new shifted average point or line, kind of the shifted x-axis, you could say, where the amplitude is going to oscillate. Okay, now, so yeah, again, it's nice. There's no shifting horizontally. So let's draw the period from 0 to 4 pi. So, okay, the cosine curve starts at the positive amplitude, but this is flipped. So we're going to start the negative amplitude. The amplitude is 2, so we come down to here. And then we're going to end there as well. Okay, now at the midpoint, it's at the other amplitude. Okay, and at the quarter points, it goes through the average. All right, now let's sketch this. So okay, now, and there we go. We've got this shift here of 1. Okay, so still we're not going to be working with a combined y and x-axis shift, but in the last two problems we will. But here we've got, so 1/2 sine 3x minus 2. So we're shifting this down to the period that we've shifted about a factor of, we've shrunk by a factor of 3 about the x-axis. So the period has gone from 2 pi to 2 pi over 3. And then we've shifted down about the y-axis by a factor of 2. So, okay, we'll be going from, let's see, if we shift down minus 2, and then we're oscillating between, by amplitude of 1/2, so it's going from 2.5 to 1.5, or minus 2.5 to minus 1.5. So let's do minus 3 to 3. Okay, now the period, 2 pi over 3, we can do, let's see, that's pretty close to pi, so let's do minus pi to pi. Okay, so now we've shifted down 2. Let's draw the mean. So, okay, each of these is 3 divided by 10 is 0.3, 0.3, 0.6, 0.9, 1.2. So, you know, right in there is the new mean line. Okay, and let's see, let's put the amplitudes points too. So let's see, we've got, we're going to be oscillating between a 1/2 up and down. So that's going to be minus 2.5. So 0.3, 0.6, 0.9, 1.2, or wait, no, we shift down 2. All right, 0.3, 0.6, 0.9, 1.2, 1.5, 1.8, 2.1. So around here. This is minus 2. Okay, and then we're going to go to minus 2.5, so minus 3. This is minus 2.7, minus 2.4, so around here. And then minus 1.5, so 3, 6, 9, 1.2, yeah, here. So that's the amplitude points. Okay. Now the period, so there's no horizontal shift, so we just need to figure out where is 2 pi over 3. So how many, if okay, we have, let's see, 1, 2, 3, 4, 5. Pi over 4 divided by 5 is pi over 20. So what is 2 pi over 3 divided by pi over 20? Thirteen and a third. So that's how many tick marks 2 pi over 3 is. 13 and a third. So let's see. We're drawing the sine curve. So we're going to start at the 0 axis, and then 13 and a third tick marks. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13 and a third. And that makes sense because, oh wait, this should be positive 3 pi over 4. That makes sense because 3 pi over 4 is 0.7, 3/4 is 0.75, and 2/3 is 0.66. So that's looks to be correct there. So all right, now we need to draw the, let's see, 13 and a third. Let's divide this by 4. So 3 and a third is the quarter points. So 1, 2, 3. All right. Well, let's see though. It's just the sign. It's sine, not flipped or anything. So we go from 0 to the positive amplitude. 1, 2, 3 and a third. So here. And then let's see. 3 and a third times 2 is 6 and 2/3. So 1, 2, 3, 4, 5, 6. 6 and 2/3. We come back through the mean axis, and then 3 and a third times 3 is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be the negative amplitude. Okay. So we've got, let's draw this. Okay. Let's see. And there we go. With this average value that the sine curve is oscillating about shifted down 2. Okay, so now we've got a horizontal shift mixed in with a vertical shift. We can see here we're going to shift to the left pi over 2, scale up by 2 about the y-axis, and shift down vertically by 3. All right, but there's no scaling about the x-axis, so the period is going to be 2 pi. So we can do okay. Okay, so now the amplitude has been scaled up from 1 to 2, and then we're shifted down 3, so we can do put 5 to minus 5. Okay, so now let's put the new average oscillating value, the y value, so 1 will be here. Okay, now let's see. We're going to be going from, we would typically go from 0 to 2 pi here, but we're shifted pi over 2 to the right. So we're going to start here and end here. Okay, so yeah, there we go. Now we're dealing with the sine curve, so that starts at the average value and ends at the average value, and then the midpoint is going to be at the average value. Now this is a sine curve that hasn't been flipped or anything, so it's going to go at the first quarter point, or the quarter point. It's going to go up to the positive amplitude, so that's going to be up 2. The amplitude's 2. And at the 3/4 point, it's going to go be the negative amplitude, so down 2. Okay. There we go. And there we go. So now we haven't, this is just the curve 2 sine of x shifted to the left pi over 2 and down 3, but in relation to, so 2 sine of x has a period 2 pi, it has whatever its frequency and angular frequency are, its amplitude is 2. That hasn't changed when it comes to the horizontal and vertical shift. So when it comes to the horizontal and vertical shift, we've got this phase shift here so the 2 sine of x has been phase shifted this amount and has been shifted down this amount. I don't know the symbol for this, just -3. This is, right, that's what's happened to 2 sine x. Okay, so we can see here, this is going to be shifted to the left pi over 4, scaled by the x-axis by a factor of 1/2, not scaled about the y-axis, and then shifted up 1/2. So you think about this is that sine of 2x is what's shifted to the left pi over 4 and up 1/2. So, okay, the period is going to go from 2 pi to pi. It's going to be scaled down by a factor of 2. So, okay, let's do, okay, now let's see. So the amplitude is going to stay at 1, and then we shift up 1/2, so we can do this. Let's see, y. Okay, so now each tick mark is 0.2. So let's draw the new average y value. That's going to be 1/2. So 0.2, 0.4, 0.6. So here. Okay, so let's see. Now, all right, the period is pi, but we're going to be starting at minus pi over 4 and then going to 3 pi over 4. So, okay, at the sine curve, it hasn't been flipped or anything. It starts at the average value and it ends at the average value. Then halfway, it's at the average value. And then it's going to go, the quarter point is going to go up to the positive amplitude. So that's going to be at, we're going to go up 1 from here. So 0.2, 0.4, 0.6, 0.8, we're going to go up to here. And then at the 3/4 point, we're going to go down 0.2, 0.4, 0.6, 0.8 to 1. Down 1 to whatever this is. So, okay. There we go. And there's the curve. Okay, so here it's been shifted up 1/2, and then the phase shift is we went from here to here.